I'm still on the mission to destroy all Mario Party DS games using code, and it's been quite a while since my last video, so let's get going. Some of you guys asked for 3 vs 1 minigames, so I thought this is a great time to tackle some of them. In Rotisserie Rampage, you're standing on a spit that's rotated by the single player. You can use the up and down keys to stay on top, but if you go too far off the sides, you fall off. Since the enemy player can change the rotation direction at any time, you have to react pretty quickly and walk in the opposite direction. Like many of the earlier games, this one can be solved with a bit of computer vision magic. Let's just assume for now that we have the means to detect the player position. The character moves in a predefined curve and we know the optimal point to be in, the center of the skewer. So when the player is on the one side of the target point, press up, and if they are on the other side, press down. But I'm a fan of simplicity, and if you squint, you may notice that the Y coordinate of the player position doesn't tell us much about the player's whereabouts. If Y is this value, for example, we don't know if the player is left or right of our target. In fact, the Y coordinate doesn't encode any information that are useful to us, so we can simply use the X coordinate for this purpose. And that turns the curve into a simple line. So that leaves us with the player position, which I claimed we have access to at the start. And it's easy enough to detect clusters of purple using simple color masks, but is there an optimal detection strategy? It should work no matter which way the player is facing or which position they are in, and return a consistent X and Y coordinate. Well, at first I thought about the shadow the player casts, but it's getting way too small on one side. It seems simply selecting purple pixels is the way to go, and to make it consistent, I settled on returning the XY position of the highest purple pixel on the screen. I implemented a small visualization to track the current player position, which you can see here. The blue lines are the bounds where I'm searching for my player. Red is the optimal X position and green is the current player position. As you can see, it's trivial to tell based on the player and optimal position which button should be pressed. So let's do that next. The logic is literally, if player X is smaller than target X, press down, otherwise press up. And it looks like the correct buttons are being pressed, but the timing seems off. If you think about it, the further away the player is from the optimal position, the longer they have to press a movement key. In code, this literally means calculate the distance from the player to the optimal position and multiply the button hold time by it. So, final test. And yeah, that works perfectly. I let it run a few more times and it always wins, even against the expert AI. But of course, we still have to tackle the other way to play this game, in 1 vs 3 mode. As the single player, you have to use the stylus to rotate the spit. Luckily, this mode is not nearly as involved as the other version, and all you have to do is spam an up and down dragging motion. I fiddled around a bit and after a few tries I found good settings that seem to always work. Going full speed and alternating directions every 2 seconds gets even the expert AI to fall eventually. So let's check out the next game. I don't know about you guys, but Power Washer was one of my childhood favorites. Wait, I actually do know about you guys. Well, at least it got to round 2. Anyway, in Power Washer you move around on a plate that's surrounded by rotating blasters. Out of them comes a water beam that you have to avoid, either by running away or jumping over it. It's a survival game with a 30-second timer, and in the last 10 seconds the other blaster turns on as well. Crucially, the blasters can't be controlled independently of each other, so they always move in unison. When I started experimenting on this game, I thought I should just detect the water beams and move away from them. I even found a pretty consistent detection method, but then I had a much better idea. After all, the water always exits the blasters in a straight line, so when I know where they are, I also know where the water is. And that is much less messy than the line detection I had going beforehand, for multiple reasons. So to get started, all I had to do was detect clusters of red and dark blue pixels in the image. Of course, there can be players with these colors in the play area, and the timer also turns red at the end. But since the blasters always move around the plate, I can heavily limit the area I'm looking in. I decided to create a mask that turns off all the pixels I'm not interested in. That means I want a sort of donut-shaped cutout of the image, and there is a neat way to get that. First, I created a matrix that has the same dimensions as the captured image. Each value in the matrix is the distance to the center element, so the four corners have the highest values and the middle element is 0. The visualization here is not quite accurate, but you get the point. If you zoom in, you see increasing numbers emanating from the center. Then I applied a simple rule to each cell. If the value of the cell is bigger than 80 and smaller than 100, the cell gets the value 1 and 0 otherwise. And since all the values between 80 and 100 are in a donut pattern, you can see how this is helpful. When you now piecewise multiply this mask onto the image, only the area we are interested in stays colored and the rest turns black. And now it's just a matter of looking for clusters of red and blue pixels. Here I highlighted the coordinates I found. So how does that help? Well, the safest point is where we have the highest distance to the water beams, which leaves us with 4 possible locations. To make it easier, we select the one that's closest to the player, of course. And now, by interpreting the input image as a circular coordinate system, with the center pixel being the origin, it becomes trivial to find our desired target. We calculate the angle theta and distance r of the blaster near the player. Then we simply add 45 degrees to the angle and subtract a few pixels from r to get the target point. I also added a green marker and the current player location to the visualization. All that's left is to implement the movement logic. Just like in the last game, it's a simple if-else to press any of the direction keys depending on the player's location. So here's the final gameplay. And to everyone who's still watching, thanks for sticking around until now. I know I haven't been very active lately, except for the daily Pokemon Showdown poll, but I want to upload more frequently again. So if you haven't unsubscribed yet, I appreciate you. Anyway, we still have the 1 vs 3 mode of Power Washer ahead. All you have to do is use your stylus to rotate the blasters in order to hit the players. It's literally the same as Rotisserie Rampage, but instead of up and down, you move the mouse in a circle. You move the mouse in a circle. I was able to reuse my utility function I wrote all the way back in the first episode for Goomba Wrangler, so that's neat. Switching back and forth every second, you can even wipe out the expert AI easily. Neat. Let's see the final game. Dust Buddies actually made it all the way to second place in my community poll, so many of you guys probably remember it well. But for those who don't, you have to flee from a vacuum and while doing so, dodge everything on the floor by running away or jumping over it. And you may think, cool, you can detect all incoming objects on the top screen and apply position prediction to move into the optimal spot every time. And to that I say, no, I will not be doing that. You may be disappointed, but you can literally just hold the up key and spam jump to win the game basically every time. Even when the objects beneath you get sucked in, since you're in the air for most of the time, almost nothing happens. I'll spare you the implementation details, well, because there are none. Here are some runs I recorded. So yeah, there you have it. And that's it for today. Before you click off the video, make sure you subscribe if you haven't yet, because there's a lot more Mario, Pokemon and other gaming content coming.